This video was in the making for almost a year, since July 2024. And it's about time I start producing content on the boxes of everything I have lying around my room. Today we are going to talk about Omote. Omote is an open universal remote. We'll start in a couple of seconds. Yeah, this is the remote. We all have it, we have a bunch of them for various devices, and most of them are classical infrared remotes. But what makes this open source universal remote different than, for example, Logitech Harmony is the simplicity. This one is definitely not simple to set up. This video will be actually first part. In this video I will be talking about the harder part of the open universal remote, and that is how you can order PCBs, components, or maybe you will opt out, and please opt out for that, already built universal remote. That's almost built 100%, that you just need to then print the case, the buttons, if you want a stand for it, and source some additional materials, which are usually not sourced with the pre-assembled PCBs. Let's start by saying thanks to the PCBWay for sponsoring this video, and I will be walking you through the process of either ordering PCBs or ordering pre-assembled PCB boards. But even if you are handy DIYer, I would recommend that you go with the pre-built PCBs or pre-populated PCBs, because there are a lot of components, a lot of small components, and you will lose precious time. Yeah, as you can see, it's working. So let's start talking about Omote, open source universal remote. This device will replace your other remotes, but don't expect Logitech Harmony experience out of the box. This is open source project, and it does require a couple of things. In this video or today's video I will be covering a harder aspect of building open source remote. But before we look at that, let's talk about this remote, what it is, what it does, what it can replace, and what to expect. As it says, it is a pretty standard universal remote. It can operate most of the infrared devices. When I press the button, you can see the light emitted from the infrared emitter. But this remote also has infrared receiver. And what that allows? It allows you to learn codes from the other remotes. So for example, if the remote for the TV, for the AC, for the AV receiver, for whatever you want to replace all remote with this one here, doesn't already have preset in the database, and warning, there are just a couple of presets already existing in the device known database, you will have to learn codes from it. And that's why it's awesome that this remote doesn't only have infrared sensor, but it also has infrared receiver. With that you can of course learn the other codes. Besides that, this remote also has Bluetooth. So for example, you can control devices that do not use standard remotes, but instead use Bluetooth remotes. I've tested it with, Chromecast or Google TV for Chromecast device, and it's really working awesome. But if you think that infrared, sender or transmitter and receiver plus BLE are the only things that this remote has, you are mistaken. There is also one additional functionality that this remote has, and that is the Wi-Fi. But why would you have Wi-Fi on your remote? Actually, to control your smart home. While the software is not that robust in terms of hooking this up to Home Assistant, for example, this still can be done. And this can be done via the MQTT. There is a pre-built package inside this remote repository that you can use to, for example, control lights, switches, or something similar inside Home Assistant via the MQTT, via the Wi-Fi connection. So this really is universal remote. The remote has a lot of buttons, so you will probably not miss any button that you already have on your existing remote on this device. The device also features the touch screen, and you can use that screen to control, go from scenes, change devices, etc. etc. Besides that, it also has accelerometer or gyro inside it. That means that the remote is always in the power safe mode until it gets picked up. So as soon as you pick up the device, the screen will lit and then you could do whatever you want to do with the remote. Control something, turn on, off, etc. etc. I've already mentioned scenes. Yes, you can build scenes. But remember, all of the coding is done by hand. There is no nice or nifty app that you can select your devices, click, finish, and everything would be set up. No, you will have to do that, and I will be talking about that in the next video. Go to Visual Studio Code, change code, compile it, upload it to the remote via the cable, and then you have a new version of the remote. So if you're not up to that, maybe this remote will not be for you. I did mention that it has power saving mode, but let's talk about battery. The battery is whatever capacity you buy. I think I have 2000 mAh batteries, and they last a couple of months. The good thing is that in the repository you can also find a docking station for it, where you plug on underneath the USB-C cable, and each time you dock your remote, it would also charge. So something similar to what my Logitech Harmony remote had, at the time when it was still working. As I said, the sponsor of this video and sponsor of this project is PCBWay, and I would once again like to thank them for helping me out with this project, because at the end, the cost of it was pretty high. There are two options or two ways on how you can proceed. You can either order PCBs, just the PCBs, and then source the components wherever you want to source them, or the other option is to order pre-assembled PCBs, where, for example, PCBWay would create PCBs, fabricate them, and then also populate them for them. I would really recommend for you to go that way, because it makes project very simple. Or simpler, because still there are a lot of tasks that you can do. So let's start by creating an order for the PCBs. I selected a quick way for the PCB ordering process. In the Omote repository, go to PCB production and download one file, and that file is gerber.zip. Then on the PCBWay website, click on plus to add Gerber file, select Gerber, click on open, and it will go through the PCB or CAD design. It detected two layers of the board. You can go for a single piece or panel by customer or panel by PCBWay. I would recommend that you go for the single piece. Select how many boards you need, and everything else you can leave alone, except you can, for example, change the color of the silk screen or the solder mask. Mine are purple, but you can go, for example, with the black ones. Just note that prices do change, and for the silk screen you can, for example, go to yellow, which once again has impact on the price of the boards. If you want to keep the costs lower, select green, select white, and maybe you can change from the HAS cell with LED to a LED-free version. Next option we have here is if you are going for the boards themselves and you want to do the assembly, you may, and I really do recommend that you go for the stencil. For that you need to click on this link here, and the stencil will be created. You can select if you want top, bottom, or top bottom, both on the single or separate stencils. For this project I would recommend, if you go for the DIY version, completely DIY, to go with the top button on a separate stencil. It will make things much easier to manipulate when you start assembling and putting the solder paste on. As you can see, this adds additional $30 of cost. Stencil is not needed, but since the stencil can help you with some pretty small components, alignment, etc, etc, if you are doing more than one board, I would definitely recommend that you go with the stencil. If not, deselect it. And for the price of $57.78, I will receive, for example, 5 of these boards from China to Croatia. There is also option to select alternative shipping if you want to save a bit of money. But let's now talk about the assembly service. What if you do not want to assemble everything by hand? Simply tick on this box here, select turnkey because it's easier for them to source part than, for example, for you to buy parts, send to them, they wait for the arrival, then do assembly. If you want to go for panelized or single piece PCBs, if there is less than 20 PCBs, go for the single version. If you want to do assembly of top or the bottom, for example, you can go for the top only assembly because it's easier to assemble the buttons that are on the bottom side. This all depends on what you want to do. Quantity, for example, 5 for all 5 boards. Does this contain sensitive components? Do you accept alternative or substitutes from China? For example, sensitive no, substitutes yes. Click on calculate, save to cart, read the terms, click on agree, and the next step we need to do is add files. Parts list, this is this bomb with diode 2, download. We will also download this CSV file, that contains the coordinates for each of the components, and it is used for the pick and place machine. Click on it, download, and then select BOM list and this CSV file. That's it. Submit order now. Everything is now ready. So far we have cost of PCBs, that is $31.94, and current cost of assembly, this is just the, let's call it like that, placeholder, is $29. It takes around 24 hours or less for PCBWay to look at the order and give you the final quote. There may be some questions from them, but usually everything is clear from the documents that you've sent. This is bill of material and also the pick and place machine list where it knows where to put each of the components. Plus, of course, the Gerber file that contains the PCB design. That's it. I don't know why, but if you've decided not to buy pre-assembled board or PCB with the assembly, you can of course then go and buy the required components. Some of the components are easier to find, while others may be much harder to find. For example, one of the biggest issues for me for sourcing was displays, and there was no way for me to find them anywhere else except the Mouser. If you are lazy to look and browse through the sites, various sites, you can go to whatever site that is selling components, select that you want to upload the BOM material list, upload it, and then you have to customize the header to select where is the description, Mouser part number, hint, this one doesn't have Mouser part number, it is using different manufacturer, but you get the point. Click on next and the parts will be migrated or moved to your basket. There are various sites that can help you with ordering process for the components, so I will not be going into details, it depends on the site you are selecting. But this is, for example, one of the orders I made a Mouser for the displays. At the time of the order, which is August last year, I ordered 10 pieces, each one cost was €19.29, total for €192.90. And the last missing component I ordered, besides display and pre-assembled PCBs, plus also all of the components for manual assembly, because I also wanted to try and build 10 boards myself, was this battery. I ordered 20 of them, 10 for the pre-assembled and 10 for the ones that I will assemble manually. The cost for the 10 batteries was €26.79 plus €10 shipping. So for the 37 something euros, I received 10 batteries for the 10 remotes. And now you will have all of the components. You will have PCBs, pre-assembled, or PCBs plus components. You have ordered display, which is not standard BOM material part, and you also order battery. But that's not all. Now you also have to build the case. The next part is the case, and this is where I had a lot of issues, because I simply didn't look at the right place. If you own a 3D printer, this will be much easier. I decided to print everything out of ABS because I prefer printing in ABS than, for example, PLA. And I think that remote should be in ABS to avoid any possible case damage when it falls. But of course, since I have a printer, even if the case breaks, I can print a new one. What you need to do is go into the cut folder, and there you will find the STL files. We will need all of the STL files here. For example, button grid, case, color buttons, cover plate, and also off button. But this was a catch for me. When I printed button grid, for example, and the cover plate, they would fit, but the fit would be too tight and I couldn't press the buttons. That's why you have additional folders called community parts. Here you can find a subfolder called small buttons, which are the buttons that are supposed to be printed with the TPU. In my case, printing those buttons not out of TPU but out of ABS fitted perfectly in the remote. So that's why I went for buttons, button grid TPU, color button TPU, and off button TPU files. Import the files into the slicer, arrange them, and then we have to position them. We also need supports for this cover here, or for this case here. Click on part, orient it in such a way that top is towards the build plate, same goes for the case, and make sure that you have supports enabled. I'm using organic supports, but you can go for any type of supports you want. Click on slice, check that everything is sliced correctly, and when it finishes, just click on Send to Printer. Repeat same with the buttons, position them, make sure that you have 4 of these are the color buttons. You can print them out of different color of ABS or whatever material you want to print. I will be using only one color. Once again, click on Slice and send it to your printer. That's it. If everything is done correctly, you should end up with something like this. This is the pre-assembled PCB board with a display attached and also battery hooked up. You should have a case cover, buttons, this is the grid button, the color buttons, power on off button, and couple of screws. You need to position the PCB inside the case, insert the button into the cover, and then just position the case on top of the cover with the buttons, and that should be it. You should now have assembled everything and are ready for the phase 2. I wanted everything to look better, so I tried printing this out of the resin. And unfortunately I had the same problem as I had with the ABS buttons at the start. They simply didn't fit well enough. When I started with this project, the revision 4 was the latest revision of this device, or this universal or open universal remote. Now, in the last month or so, the new revision 5, was released. This one has a couple of improvements. First of all, buttons have LEDs. The second improvement is the change of ESP32 controller that it is using. Current Pico one is small and efficient, but unfortunately is very limited in terms of RAM. The newer version has more RAM that can be used, and that means that the device will run snappier, and also some additional functionalities may be ended up in the future, which the revision 4 cannot handle. No worries. If you order today, the revision 5 is the revision that the Gerber files are for, and the bill of materials that is also included. That means that if you order today, you will receive revision 5 of the Omote, or Open Universal Remote. I apologize for the length of this video, but I did want to cover all of the basics: how to order everything, where to find parts, how to assemble things. And when we are already talking about assembly, let me show you my struggles with the hand assembly of one of the PCBs. Yeah, I did, as I said, order additional 10 PCBs for me to manually assemble them, instead of using pick and place machine at the PCB way. And that was actually a mistake. It takes me around 3 or 4 hours to populate everything. First, what you need to do is you need to put the soldering paste on. For that, you need to use the stencil that was ordered at the time where the PCBs were ordered. That's not that hard, but the problem for me is that I had a couple of syringes of the soldering paste, and it looks like all of them were old, which will bite me 2 times down the road. So you use stencil, you apply the paste, you slowly take a microscope, and I do have a great electronic microscope for that. I put on my glasses, tweezers, and as I said, it took me around 3 hours with breaks to assemble everything correctly, to make sure that I don't mess things up, to make sure that every component is placed where it needs to be placed. And I'm not sure if this was worth, because after using the heat plate to heat everything, to solder everything, the 2 boards that I did assemble unfortunately didn't work. So now I have 2 boards that are assembled, but I need to debug, I need to desolder components and figure out where is the short. And it's not that easy as it looks. If I would need additional remotes, I would definitely go for the assembly service plus PCB during the order. In terms of the size of the components, remember, these are small components. We are talking about 0603s. There are some bigger ones or larger ones, but most of the components are 0603. And this is a really tiny component. I've lost a couple of them when I sneezed, and yeah, that's no fun. On the other hand, I also had the fun of assembly. It was just a bit frustrating, yeah, when those 3 hours were gone in the wind. But who knows, maybe my 3rd, 4th, 5th, 6th, 7th, 8th or 9th, maybe 10th time that I try to do that, the remote will work, because I do have components and PCBs for 8 more. In the next video that will be published in 2 weeks, we will be talking about software, because hardware itself will not do anything for you. I will show you how to program them, how to use presets, what can you do if you want to create your own preset, how to hook it up with Home Assistant, and much more. And at the end, I will talk about my experience. So far, the experience really was great, but it's not that easy as it was with the Logitech Harmony, because for that we had the app, we selected type of device, manufacturer device, we had a couple of templates, selected template that worked for us, and that's it. Here we will need to go to the VS Code and change a lot of code by hand. Until next week, I really do hope that you did enjoy this video. And if you did enjoy this video, don't forget to give it a thumbs up and also check that you are subscribed so that you don't miss the next video where we will be looking at the software and how we can program the remote to do what we want. If you have any kind of a comment, question, if you have a suggestion for a similar project that you want me to try and tackle, don't forget to leave it down in the video description below. And before I end up the video, I want to say thanks to all those wonderful people that are supporting me and that have become YouTube channel members. Thank you all for all of your support. But let's not forget each and every one of you who has watched, shared, commented or liked my videos. Thank you. If you too want to support the channel, you can do so by clicking the join button down below and becoming a YouTube channel member for only €2 or $2 per month. Or you can go to my merchandise store and get something there. Last but not least, you can always send me super thanks and I will be super thankful for that. I will be seeing you next time. Until then, bye bye and have fun.